Fantastic. So welcome everybody to the UC OSPO Network Open Source Meetup. And if you haven't yet, please check out the meeting notes and add your name and answer today's getting to know you question. And the plan for today is we have a couple guest speakers who we've asked to tell us about how AI is changing open source workflows. And I think you'll see that they have both given a lot of thought to this question and have a lot of insights to share from the researcher perspective on this topic. And so we'll do that for about half an hour, have some discussion, and then at some point in the second half of the meeting, we're going to kind of transition to sort of a community call. So if folks have questions about what the UC OSPO network is up to, we'll have some updates for you, and we're happy to answer those questions. So I think with that, we will hand it over to Kat and Carlo. I'm not going to be able to do an adequate bio, so I'm just going to say that here at UC Santa Barbara, we have the NCEAS Institute, which stands for, oh my gosh, I always struggle, National Center for Ecological Analysis and Synthesis. Basically, they're a bunch of scientists and data scientists doing fantastic work on ecology and environmental research. And I know both Kat and Carlo are very involved in not new, but a project that's been making headlines recently called the Wildfire Resilience Index, and doing some research onto how to make communities more safe for from wildfires. And with that, I'll let them each do a better introduction of themselves and their work.
Yeah, hi, I'm Kat. I see Carlos signed on. Oh, and he's present. Um, let's see. I am a researcher or a senior fellow, whatever you feel like calling me, at the National Center for Ecological Analysis and Synthesis. And for the last 3 years, I've been leading something called the Wildfire Resilience Index Project, which was a team science project I led with between 5 and 6 other data analysts or scientists contributing to the project. So a really big group effort to do this kind of work. And Carlo, if he wants to introduce himself briefly, was one of the data analysts on the project.
Hey, yeah. About 15% of my job is working with Kat on science and ideas and how to explore wildfire science. And the other, let me do some data science really quickly. 85% is I'm actually just a telephone between her and computers, specifically our big high performance computer, right? So like she wants to investigate something and I communicate her desires into code and other kind of information that the computer can crunch. And so I did that for the Wildfire Resilience Index, and we're still doing that and kind of expanding the index. But the index is really wide in our approach to what wildfire resilience is. So we investigate a lot of different things, and so I just translate what we want to investigate into something that a computer can answer easily.
All right, and can you all see my screen?
Yeah, looks good.
Okay, often I share incorrectly. So today I'm standing in for Rachel King, and I'm going to do my best to do justice to the slide deck that she put together. Um, but what we're here to talk about today is how AI, and specifically generative AI for coding, has changed the way that we do work at scale and as a team. And we're going to talk about this in the context of a recent contribution that we put together called 10 Simple Rules for Generative AI in Environmental Science Coding. And just sort of talk about what this effort was. The paper should be coming out in the next few weeks or so. It was just accepted. But the rules in the conversation were really around, how have things changed? What does that look like for those of us who do data science? And what do we want this future to look like? So I'm going to talk, but I feel like this is a relatively small group. So I feel like if I say anything super confusing or wrong, or you have any questions, just interrupt me. That feels totally fine. And so then Carlo's role here is to answer really the more technical side of the questions. I would argue that I'm more of the project manager. And while I have gotten into generative AI coding and coding tools recently, Carlo is, and we'll go with an AI evangelist. So he is the one who's really in the weeds on these sort of things. All right, so NCEAS is a community of people who use data science to ask and answer questions about pressing environmental issues. And as such, we've all been sort of grappling with the emergence of these AI tools and techniques for the last couple of years. And so I think it was earlier this year, we put together a workshop where we brought together, oh, I think I need to progress my slides. I can't. Ah, where we put together, let's see, we go. I'm just going to fill this out. We put together a workshop where we brought together 30 or so people in this space. We included researchers, data scientists, instructors to talk about what Gen AI is, what it looks like, how we're working with it, how we're dealing with it, and to try to put together some guidelines because we all feel like we're sort of just grappling in the dark to figure out what these tools are and how to use them and how to be responsible and ethical and effective with them. And so we brought together a bunch of different practitioners and talked to people about, what it is, what are they doing? Are they doing anything? Do they have reservations around AI use? What do those reservations look like? And we tried to create some guidance around what our community of practice can start thinking about when it comes to Gen AI use. And I think a lot of the times when we talk about how to use AI in our workflows, it can be really abstracted, which can make it really difficult to connect these principles and guidelines to the specific things that we're doing. And so the reason that Carlo and I are here today is because these rules have real world examples in the actual work that we've done for the last 3 years. So in this paper, every single rule is paired with an example from the project that we've been running to help sort of ground this in reality. There we go. All right, so I'm just going to march through some of these rules. And again, if you disagree or have questions or want to seek clarification, that's really quite welcome. So we wrote this for PLOS computational biology, which means that we were constrained to 10 rules, and we came up with 10 rules that really partition the workflow into before, during, and after. So the first three rules are all about before you start coding and figuring out how to set yourself up for success. And this was an area where the people who work in education and instruction had a lot of opinions and really shaped what we put in this set of guidelines. And so, rule number one is you need to understand your domain and what you're doing, right? Gen AI has the ability to sort of just let you explore and try new things and go down paths that you may have not gone down before because you're not familiar with them or the technical barriers are quite high. But one thing that we've noticed is that especially if you are trying out a new type of analysis or a new type of workflow, if you don't really have a solid grasp of the foundation of what you're trying to do, you can get caught up in just sort of following along with suggestions and you lose control of the workflow. So before you start in on any effort or project, or or try to execute any task, I think it's important to have enough domain knowledge to be able to direct the model and to be able to catch incorrect output as you go. One of the beauties of Gen AI is that you can use the tool to help you learn what you're doing. So I think it lowers barriers to participation that way. But making sure you really understand what it is you're trying to accomplish is a necessary first step. The next thing I think is important to think about is figuring out what tool is the right tool to use. There's been an explosion of Gen AI tools and AI tools in general, as I'm sure you all are aware of. And we found that trying to match the tool to your task is really important. The different tools are good at different things. And for both better and worse, this is a really rapidly evolving landscape. So what's doing well changes, and what tools are available changes on a daily to weekly basis. So, like for our project specifically, what we found was that just sort of the chatbots and the interfaces were really good for ideation and exploration and just doing some beta work. But that when you started to do like fully integrated software development, using AI native IDEs were much more effective, particularly as your code base grew, as your tasks became more complicated. Having your AI agent integrated directly was much more effective. So, depending on where you are in the phase of your project or your task, the different tools are going to support your work to different qualities. And then rule number three is to set up your platform deliberately, right? So as you're starting to engage with these different platforms and tools, you can customize them to work for you in the way that you want them to work. And so in some cases, this is really iterative. You start getting feedback that you don't like, or you start getting formatting or file paths or patterns that don't really work for you, and you can go through the process of correcting as you go and build out these guidelines. And then sometimes, like for our team, we wanted to have a code base that was unified and all worked together and sort of shared an aesthetic and a style. And so Carlo developed a set of rules that everyone on the team uses to make sure that the way that our scripts work and work together is the same. And so it makes sense to somebody coming in externally. And so setting up that platform can save you a lot of time and effort as you increasingly rely on these tools, if you increasingly rely on these tools. The next set of rules pertain to while you're working with AI. So we've moved from your setup and your before into your doing of it. And the principles of these rules are mostly about how to do this safely and effectively. So our fourth rule is around the rule or the guideline of least privilege. So giving your AI agents, your AI tools, as little permission as and information as they need to do their task. And what this looks like is going to vary based on your project and your work environment. For us, we work on a shared server, a shared computing system. And so we needed to give our AI agents access to that shared server, but we needed to limit what it could do, right? We couldn't just let it run amok and look in everyone's folders. We had to scope its permissions to make sure at this point it can look in my folders, Carlo's folders, and our shared folders, but it can't just look at everyone's work at NCEAS. That would be a little bit inappropriate and out of scope to allow that to happen. Um, we, let's see, we also need to set up some guidelines around data privacy. So this is something that we don't have to work with that much. Based on the type of project that we have a project that is entirely built on public data, which means that we carry very limited privacy or security risks. But the moment that you step into working with survey data or anything that requires some sort of permissions, indigenous data, issues of these sort of data privacy and sovereignty, you need to make sure that you're setting up your system so that your AI agents don't have access to that private data because we can't really control privacy once they have access. So the guidelines here are really around setting up dummy data to work with and not allowing your AI agents to have access to those folders. And then the last rule is a little bit more general and is not necessarily about these sort of privacy and access issues. But if you're not working with even if you're working with an AI agent and you're working in an interface where you are chatting with a bot effectively, um, it's useful to manage your long chats, right? So if you're asking the same agent to do like six different tasks, it can get really confused and you start becoming really ineffective. And every time you ask a question, it has to read through the whole history and figure out what the context is and what it's trying to do. And so within your platform, splitting up your chats by discrete tasks can be a really useful way of managing information as well as creating READMEs as you go so that new agents can scale up really quickly. And then if you're just like using a web browser like ChatGPT or Claude, managing your context is useful because, as a human, as you go through your project, you can change your mind multiple times, and that works perfectly fine for people. But for chatbots, this kind of changing of mind can cause this drift and context rot, and the quality of your answers can go down over time in a way that's really frustrating as a human. And so, one of the ways to sort of preempt this is to have this context window in mind as you're managing information. All right, and then the last set of rules are really after the project's wrapped and a little bit more forward-looking. This is about trust and longevity in your project. And so rule 7 is all about verifying and validating output, right? And this really pairs well with rule 1, which was knowing your domain and having expertise. Code that runs can still be wrong. I'm sure we all know this. But building in ways to make sure that you're checking things as you go is really, really, really important. So for our team, we really focus on data visualization, and that's because most of our data is geospatial. So when we were finding things like fire stations in the middle of the ocean on our project, we knew we'd done something wrong. That's a pretty easy check. We also do a lot of cross-model reviews. So we'll have code that's developed by one platform and then is externally checked by a different tool. So if you write all your code in Cursor, you can then feed that code into like a Claude chat to make sure that you're getting validation in that way. And then at the point of writing this, and this is probably no longer true, we also had a step where a real human reviewed every single line of code for the project. Rule 8 is around documenting your process. So you can use the chat that you're working with to do the documentation of your project. You can have your chat write READMEs. We think it's also useful to have external documentation of what you're doing and why you're doing it that's independent so that you don't have convergence or drift that's sort of out of your control. What Carlo and I do at this point is we still keep an active list of GitHub issues that are our living decision log. And that can help us keep track of what we're doing, help us write our supplement, and make sure that the tracking of these things isn't just completely folded into our AI system. So a little bit of independence there. Let's see. Rule 9 is about making sure is so like we all know that when you're coding, when you're writing, when you're doing these things, there's these best practices that just exist, like having modular code and having things really well annotated. And so when you're going through that documentation process at the very end of your project, you can use your generative AI tools to help you with that, to make more complete and comprehensive READMEs um, and annotations. And so this is a place where you can use AI to do some of that work to increase the transparency and reproducibility of your work. And then our last rule is the rule that I think got the most pushback on the paper is, you know, I would say Carlo and I are definitely on the side of being AI evangelists. We use these tools every day. It does a large amount of the work that we do at this point. And I think that it has elevated the role of scientific thinking and trying to figure out what it is that you want to know more than it's elevated the skills of knowing how to do that work. And so, the final rule in this project is preparing for a code-free future. And what does that look like? What does it look like when you no longer are actually typing out lines of code and everything is run through an agentic system? And I'm not saying that's necessarily going to be the reality, but I think that it's something to prepare yourself for and to start thinking about, like, well, okay, what skills do I have? What skills do I need to develop when the actual line by line coding is no longer the bottleneck? Like, what does that look like? And so, some of the concerns that we raised in the paper and some of the concerns that came up in our workshop, because again, Carlo and I are probably on the pretty far side of being AI adopters, is like, is this actually what we want for the world? Is this what we want for our day-to-day lives? Um, how does this growing use of AI intersect with the broader aspects of society and what we think about our place as practitioners here? And so we talked a lot about sort of equity and access when it comes to AI and AI coding. And the data are not super positive. In my idealized world, generative AI and AI tools lower the barrier to participation. They bring more people into the fold, and we diversify the types of people who are doing this work. But the reality and the data don't really support that. At this point, there's massive skews in gender for who actually ends up adopting these AI tools. It tends to mostly be men and not women. It tends to mostly be people who are mid to senior career who are benefiting the most from AI tools, and our most junior colleagues are the ones who are being left behind. There's inequities by wealth and geography. It's the wealthiest countries and the Western countries that are using these tools the most. And then, frankly, uh, the era of sort of free AI tools, I think, is going to and is continuing to collapse. Carlo and I, at this point, both pay for AI systems because that is where, like, that is at this point what we need to make our work work. We talked a lot about workforce policy and how this is going to disrupt industry. We've started to see that, though honestly, things are moving so fast that I don't know. I think the concerns around workforce may have shifted in the last 6 months since we had these conversations. Um, and then I think, we're an environmental data science center. We talked a lot about the environmental costs of this kind of stuff. So what does it look like from environmental perspective as we continue to lean on these tools more? We're starting to see that data centers are building their own energy infrastructure and that energy infrastructure isn't necessarily clean. So how does that intersect with our values as environmental data scientists? Like, this has been a point of really active conversation in this group. So with that, I'll figure out how to stop sharing. Um, with that, I think we're happy. Hi, Milo. Carlos, little man. With that, I think we're happy to take questions or hear feedback or anything else. Thank you for listening.
Thank you, Kat. I certainly have questions that came up for me. both of the philosophical and technical varieties. But yeah, let's open it up. We've got maybe 15 minutes or so for discussion. So what questions came up for you guys in the audience?
Or
Laura.
AI is just so clear, we're all good.
Yeah, yeah, it makes so much
Yeah,
sense.
it's totally the way it is. Um, you mentioned setting up like guidelines for the use on the team, and I wondered if you can speak freely about how the adoption is going of those rules or guidelines.
Yeah, so everyone, so the guidelines that I just went through were like the more in the weeds, like how to make your AI work for you.
Whichever one you think is most relevant.
Yeah, so I think we got consensus on these 10 rules from a group of 20 co-authors, which is like a massive lift. So I think that folks feel pretty good about the rules that I presented. The the third rule I think was about setting up your platform, and for that, Carlo has written a series of rules that are available on GitHub. And I think that I've had a lot of people adopt those. And we're starting to get some feedback on them that's been really useful, right? Because Carlo wrote them for our project, and we're a geospatial project, and Carlo and I are not junior colleagues. And so, for example, I had an intern try to use the rules, and like they started at way too high of a level. And that's great feedback because we can start like the rules prompt your system to give you a questionnaire, and the first question she didn't even know the answer to. So we're starting to calibrate that in a way that I'm hoping can be more useful. It is a living document, and I'm hoping that, as people use it, they would definitely tell us what's terrible so we can fix it. Yeah, I will get Carlo to figure out how to put that in the chat.
Yeah, you will.
Yeah, I will. You can multitask.
Yeah, I'll do it. I'll do it right now. Also, yeah, so just really quickly about rules. So there's like when I heard you ask that question, I was there's a little bit of a confusion in vocabulary. There's rules like UCSB like might have rules about like plagiarism or like using these tools like which is like labor rules or like Cat might say, don't ever do this with rules. I mean, we don't that's not the case. But then the rules that I created, those are rules for the AI, not for the agent, not for like a human. And it's because the agent wants to behave in a certain way and that way changes from day to day based on the models you're using, but more and more that the way that the agent wants to behave is like a high-end software developer, right? And we are high-end data scientists, right? So we're data scientists, and that's different, right? We want a linear chain of thought script that others can follow step by step. And we want that to be easily understandable and readable um, and publishable, right? Whereas software prefers modularity, where there's a script for each individual piece, and that doesn't really lead to a linear chain of thought. You would have to open up multiple files and like all over the place. And there's a bunch of more examples like that. And so my rules kind of pull it into the kind of reproducible chain of thought coding that we tend to prefer for science.
Yeah, with annotation for decision making.
Mhm.
Jared says, how did you limit the agent's access to your data and privileges? How comfortable were
Oh,
you with
Kat, can I
these?
interrupt you?
Oh, totally.
I believe Derek had his hand up
Oh,
first before
sorry.
you
I will
made your
Whoa.
It's
comment.
Well, it's literally the same question. So yeah, so
Okay,
in general,
great.
so okay, so like how I'm in practice, like how did that go? Because everyone's aware there have been some pretty high profile security incidents around AI agents recently. There's also like some discussion about whether those people haven't configured their environments properly. So like just in
Yeah.
practice, like what did you see? How easy was it? What did you run into?
I
Do you
can
want me to take this,
answer.
Kat? Okay, you
I was
got
gonna
it.
say I'll answer from a project perspective, and then Carlo, you can answer because you give AI access to more parts of your life than I do.
Totally.
From a project perspective, we work exclusively with public data. Like, and so the concerns are incredibly minimal. Um, Carlo perhaps allows AI to have more access to his systems.
Yeah, that's true. So there are things that we don't care about getting out there, which we want hackers to come and steal all of our reproducible data science wildfire code and spread it everywhere on the internet, right? But there are things that we worry about, right? So communication channels like my email, um, or access to compute, like access to our high performance computer, right? So we have different AI systems. One is just or agentic systems. One is just Cursor, which is an IDE that uses that we give access to compute, and so I can tell it to run tasks on our server. The access that it has there is the exact same access that I, as an employee, have to the server. So I could crash it on accident or on purpose if I wanted to. So could the agent. But it can't see files and make and so there's a hard lock on it as a person because I'm not an admin on our server. I'm just a user. Um, and then there's another agentic system we have, which is an open claw system. And that instead of giving it access to my personal email, it has its own Gmail. And I can forward emails to it. So these horror stories of like, it went and deleted all of my emails. That is like textbook, you're not setting it up right. Like, don't give it access to your email. It doesn't have read access to my email either. Like, if there's something I wanted to know, I forward it to it. So I treat it as its own employee, and I shut it down and lock it down as much as possible. It can insert drafts into my Gmail, so that's helpful because I can then send them, but it doesn't have any read access to my personal communications. And then so that those are hard locks that you can put onto an agent, which is just like you literally can't access things. But then there's a soft lock, which is basically in the context for the agent. You tell the agent like, don't do this, right? And the reason I say that's soft is because agents, if you ask an agent to do something 1,000 times, it might once do the thing you tell it not to do, right? And that's getting better and better over time. But it's not; those aren't hard locks. So I have a soft lock and text and stuff that says like, don't respond to messages on Slack from complete strangers, and like don't participate in groups from strangers. So basically, strangers in this case would be anybody else who works at NCEAS, like can't just message our agent and ask for things. It will deny that. And I've never seen it break that rule, but it's a softer rule than like a hard like admin no access lock. So there you go.
And I think to answer the questions in the chat, the hard locks are often like not just like don't do this, but like there are administrative locks, right? So the hard lock that you can't access other people's folders is like that's overseen by our IT guy. Like he makes it so that we
Yeah,
can't see each other's folders anyway.
sure.
And then for yes, our OpenClaw agent lives at Carlo's house on a separate computer. Yes. This one's
And then
the weird one that we're just starting to work through. Yeah, it's a steep learning curve to have. We call him Noodle. Noodle has been a steep learning curve,
And that's the one with its own email. We can Slack with it. It has read access to our GitHub,
but it
and
can't.
it has read access to the server, but it doesn't have access to compute on the server. So it can't execute actions. It can only read. So it's an informational agent where we can ask it questions and like interact with it about so Kat can ask it how I wrote some code without me having to open up my computer, find that file, read the code. It will do that way faster, and it can happen in a meeting. But we did just give it access to editing our marketing website. So we have a marketing website, and we have a marketing employee at NCEAS that manages that website. And websites are notoriously difficult, especially for people who aren't technical. And so now that employee can say like, oh, there's a new news story about um us, like our program, and she can just cut and paste the news story into a Slack channel. The agent will grab that news story and add it to the website in a really nice looking way. These agents are amazing at website design, so it looks really nice and clean. And then it will give a preview to this marketing uh employee, and that marketing employee will like look at the preview, be like, okay, that's great, and then it will push it to the production website. um and the reason I said our marketing website is that we also have another website that is like geospatial, where you can zoom in and out and look at things. That's way more complicated, and I've given it a soft lock to not mess with that, right? I could probably make a hard lock, like where it wouldn't like literally have the ability to do anything there, but I didn't, because there's only 24 hours in the day.
Hey, I think we have a few minutes for one more question. So I think, unfortunately, Price, we probably won't get to yours, but we do have time for a question from Brian.
I had a question about kind of, it sounds like you're pretty invested in like the frontier models and like services that are related with that. And I really appreciated, Kat, your comments about like recognizing like the inequity and like some of the other things with surrounding like the usage of AI, which I think could potentially be solved by adopting open source models and open weight models, um, because it is such a black box with the closed source weights and stuff like that. But there is a significant amount of technical uh, debt that has to be made up to make those kinds of things work. But where is that kind of in the scope of uh, your priorities as an organization? Is it, to move to something like that?
Yeah,
Um,
these are good questions.
Can I answer that, Kat? I have a good answer for it.
I'm curious because I'm guessing our answers are going to be different.
Okay, my answer is 100%. We are going to get on open source models, and probably the future looks like UCSB or your university having a high performance computer just churning out tokens for you. um how and so I am so excited about like not paying these people anymore, having it local, but I think that's 2 years away, right? If not more. Or if not less, right? And the reason why is that the open source models right now just do not have the um like intelligence to perform at the level that we're getting from the paid models.
Yeah. Um,
Is your answer different?
a little bit. So our director of research and information, I think is his title. Whenever we talk to him about this, he's like, well, just make your own agents. And I'm like, well, I don't have the technical expertise to do that. I just want this thing to work. And so, given he's the director of research and information, as Carlo said, perhaps he will make this for us and then everyone will be happy. When we talk, I've brought this up with the director of NCEAS a handful of times because the equity issue just like really grinds my gears. And what he says that's quite fair is the level of model that I'm paying for, which I am not Carlo, but the level of model I'm paying for is a subscription to the tune of $20 a month, and it more than meets my demands. And that is comparable to paying for Microsoft Word. And so the grant that we're on pays for it. My sense is that eventually the university will get a subscription at a
Nice. Yeah, I'm gonna pick up from Kat because she froze, but yeah, I mean the university is gonna
scale where
get
they can
a
offer discounts to
subscription.
students.
I got you, Kat. The university is gonna get a
Um,
subscription,
Thank
right?
you.
And hand this out. Yeah.
Yeah. And that, like, as Carlo has pointed out to me many times, like the quality of ultimately what we're doing is not that complicated. Like I want to run some regressions. I don't want to build like a security app. Um, so these things are going to become increasingly cheap, I think. And then to answer Chris's question in the chat super quick, how do we become comfortable with no humans reviewing our code? I still review most of my code, especially if I'm going to go publish the paper. Um, but the reality is that like when you're doing your beta versions of everything, it works or it doesn't. And we do all geospatial stuff. So Carlo makes me these beautiful HTMLs where I can go and directly look at things and you can check if things line up in a way that I think makes a lot of sense. But then yes, for publications specifically, I still do the line checks.
I think it's exactly the same as it used to be. Like I trust machine written code more than I trust human written code at this point. Like I feel like the error rate is higher with people writing it, and you can get to the end of the
Agreed.
analysis, you can write everything yourself, and then you'll be like you'll just look, and then you have to do the work that we're doing anyways right now, which is reviewing it, right? Like, do the distributions make sense? Like, does it line up on a map? Is it in the right hemisphere? um does the source data, just like all of that stuff, you do that at the end, and everyone's made it to the end of a script they wrote themselves and see that the distribution is off, and then you're like, crap, what do I do? Like, and then you go back through step by step, seeing where it happened, and that just still happens. Like that part hasn't changed. But I do see a world in the future where the bottleneck becomes the human review of of that, and then that itself gets automated. Um, and then we're just chugging through the endless frontier, with with an agent at our backs. So that's my view.
And again, even within our organization, Carlo and I are on the far end of this stuff.
That's true. I spend about $400 a month on AI, just so you guys know. Cat does not. I do. Half of that is probably personal use, and then the other half is work.
I have another question. You said a super spicy thing about
Uh-oh.
trusting the machine written code more than the human written code. I was
Totally.
wondering, do you feel that way globally, or do you mean you trust machine, like the agent written code, when it's being prompted and guided by a human who really knows what they're doing versus
Yeah.
a human who doesn't? Or is it just like it's always better, just always?
So
I
this
think.
I can give the
Yeah.
spicy answer to this one.
Yeah.
Like so as some what am I? I'm 10 years post PhD with several dozens of papers. That's not to be like an ass about it, but like sometimes I know what I want, right? I'm like, this is exactly what I want. I want this data layer. I want to do these filters. I want X, Y, and Z. And sometimes my ability to convey that to an AI and do it in like a iterative way versus my ability to tell that to an analyst and a junior analyst and an analyst to implement that that is a much slower process to a real human, to a junior analyst who is still learning. On this team, I had three and no, I had five. And for three of them, I continually caught errors, like as a human reader. And so there's pain points either way you go, right? But the whole point of having junior analysts, like the whole point, I think, is to train people and to help with that process. And that's what I feel like is being cut out. Because the reality is, as somebody who is soft money and on a budget, it is it is faster and the output is better for me to just tell an AI what I want. And that sucks. Carlo, if you have a less spicy answer, go for it.
Well, I think you can now have 10 projects with one analyst on each one of them instead of one project with 10 analysts, right? I think that's an optimistic view. The truth is, we have no idea what is going to happen with labor, with all of this stuff. And the other thing is that like a year from now, this conversation is going to be completely different than the next year and then the next year, right? So the speed at which this is, and like I would not trust somebody to use these models a year ago to make code. Like I think it would be like kind of even. I'd be like, how expert are they? And then like a year from now, it's just like no one has any idea where this is going, but it's going fast, and the direction is the models are getting way better, way faster, way cheaper, um, all of that. So and the implications for the labor market and training and education are just completely unknown. And I think let a million flowers bloom, and that's the only way we're going to find the right way, right?
Thank
All
you.
right. And on those spicy end notes, let's give a big round of applause again to our speakers. I think this was a fantastic presentation and discussion. I know we all have ideas about AI and opinions, and whether or not you agree with them, I hope that you learned some stuff
Oh,
um,
totally.
from our two speakers. So, now I think we don't have a lot of updates, but I think we have a couple updates on UC-OSPO Network and what we're up to. We'd be happy to take some questions as well, but I'll hand it off to Laura.
Thanks, Virginia. So we just have two small updates from the network. Things are sort of quieter over July, it seems. And maybe I'll see if Stephanie wants to announce their meetup next month.
Yeah. Oh, hi. Yeah. Yeah, I guess we're in charge of the meetup in September, and we're still, I will admit that we're still worried back and forth on our topic, but we, at the moment are looking to deal with, or to talk, bring in folks to talk about, mentorship as a way of, building community, particularly in the, academic open source world. Uh, in particular, I've worked a lot with like groups like Google Summer of Code and our own open source research experience program here at UCSC. And then Emily's also worked at Emily, who will also be involved, has worked on other types of mentorship programs. So we'll likely have folks coming from who have worked on these programs with us, either both students and mentors, as well as I'm hoping to get someone from GSOC to also talk about how they interact with open source projects. So that's it may change, and I will make sure that Laura knows to get the information out very soon about who's going to be talking at that meeting.
Thank you, Stephanie. And I'm just looking, I saw Kat's comment in the chat about being around for follow-ups if there's interest. And I'm just going to drop a link to our Slack workspace, which would be an excellent place for follow-ups to take place. So that link is in our notes, and and it's in the Slack chat too. And let's see, the other announcement from the network is that we have scheduled our next hackathon in the Reboot the Earth series, co-hosted with the UN, and that'll be the 23rd and 24th of October at Davis. And I see, oh, Kirsty has a hand up. Go ahead, Kirsty.
Yeah, so I'm sorry, I should have added it. I was listening to the really interesting discussion, so I should have been adding. Um, I I want to just share a blog post from an event that we ran last week. It was really fantastic. So the project is called Light Cone Research, and it is supported by Eric and Wendy Schmidt, and it is a collaborative event hosted at Berkeley Institute for Data Science and the French National Science Research Centre, CNRS. And they ran a developer summit, a collaborative 4-day event. The blog post, they are our dream team because they've turned around a blog post so quickly. The event was literally last week. But I wanted to share it because specifically they are working on open source tools, standards, systems, educational opportunities to make sure that as we move towards using agents much more for research, they are tracking provenance throughout the decisions, and there are clear accountability mechanisms for who made what decision or why at each of the different stages. So check out that link. It was really, really fantastic. It's very, very motivating to be thinking about interoperability and openness as it relates to using AI for science.
Thank you, Kirsty. And Tim.
Yeah, I put in the chat that will be as part of the UC Carpentry's annual fall workshop series, which is a classic Carpentry's set of lessons, so either Python, R, Git, OpenRefine, and Bash Shell. The following week, we'll be teaching a collaboration between UC-OSPO and UC Carpentry's to teach a relatively new lesson that we wrote on how you share research software. Like, how do you get cited for it? How do you make it discoverable? All the kind of top tips to getting a DOI, what a citation file is, how to structure your README for software, how to do all the basics that we think are important, up and to the point of actually, I think we have an episode on using Pixie packaging. So check out the lesson. It's alpha, so we appreciate other people piloting, but we'll be piloting it in September.
Thank you, Tim. And Stephanie has one more.
Yeah, I didn't know if I had time to say it, but I did want to highlight, I put in, oops, that is not the right, I do not know do not click on that that link. I think that was a link. Anyways, I will put a corrected link in here for a set of blogs that Nithya Ruff has recently put on the Linux Foundation, and like I said in the note, it is related to like a follow on to the discussions that she had at the UC Open. So she wanted to specifically let me just edit this real quick. So I don't know why I put a calendar link there, so I apologize. Now this should be correct.
I think I just
anyway, this is
it.
That's the last one, and there are links within that document to the other blogs. She did a great series on academic open source and how industry and foundations and open source communities can work together with academia. So and like I said, it's directly related to the UC Open talk that she gave in Berkeley in April. So.
All right, well, thank you so much, everyone, for joining us. Any last words? Anyone will be heartbroken if they don't manage to fit in today. All right, great. Thank you so much again for joining us. Thank you again to Carlo and to Kat for lending us their expertise. I hope that we will see you all at the next one on the 3rd of September, and have a wonderful August. Bye-bye.